Hello everybody, get ready to start lesson 5.3 part 2 of pre-calculus math today. And today for your classwork you have 2 points here for your notebook, 38 points on your class worksheet. If you need class worksheets, email me for those. And we're going to go right in. No bell work today with our classwork. First page of our classwork here. Equations of quadratic type. Many trig equations of the quadratic type ax squared plus bx plus c equals 0 as shown below. So to solve equations of this type, factor the quadratic, or when factoring is not possible, use the quadratic formula. So quadratic and sine x. 2 sine squared x minus sine x minus 1 equals 0, and 2 sine x squared minus sine x minus 1 equals 0. So quadratic and secant x. Secant squared x minus 3, secant x minus 2, and then secant x squared minus 3, secant x minus 2. Those are two different kinds of quadratics within trigonometry. Factoring an equation of a quadratic type. So find all solutions of 2 sine squared x minus sine x minus 1 equals 0 in the interval of 0 and 2 pi. So treating the equation as a quadratic in sine x and factoring produces the following. So we have our original here. And then when we factor out 2 sine x plus 1 times sine x minus 1, which would be the equal to this expression up here. So now we're going to set each one of these equal to 0. The following for that, when you factor those out, in the interval 0 to pi, 2 sine x plus 1 equals 0, and sine x minus 1 equals 0. So when you solve for 0 here, you have sine x from here equals negative 1/2, and on this side you have sine x equals 1. So for this situation here, sine x, when it equals negative 1/2, would be 7 pi over 6 or 11 pi over 6 in this interval here. And then sine x equals 1 would be x equals pi over 2. And then this would be the graph here. This shows you your zeros here. You have 3 zeros within 0 to pi. And this will be pi over 2. This will be 7 pi over 6. And then this will be 11 pi over 6 here. So those will correspond to your zero there. So the x-intercepts are in numbers here are 1.571, 3.665, and 5.760. You can conclude that the approximate solutions of 2 sine squared x minus sine x minus 1 equals 0 in the interval of 0 to pi are here. So they're up here is what they are. From that, by graphing it and also solving it, making these into real numbers here is what that correspond with your graph up here. Let's try one now in the interval of 0 to pi. Try collecting alternatives, blah, blah, blah. We've already done that, so let's solve this one here and then graph it to check our calculations. So for this one here, y equals 2 sine squared x plus 3 sine x plus 1. And then in this case, x here would equal 3.6652. After graphing it, you would come up with these 5.7596 and 4.7124. This would be your graph here of this function here. And by checking that, going into your table, you would be able to confirm these values here for the zeros of this function. So getting into another example here. Rewriting with single trigonometric function, solve 2 times sine squared x plus 3 cosine x minus 3 equals 0. So I got a grid up here ready to use here. Begin by rewriting the equation so that it only has cosine functions. So we need to convert this into cosine. There's the original. So when we factor out a 2, this becomes a Pythagorean identity here. And then we have 3 cosine x minus 3 We leave that. And then this becomes 2 times cosine x squared minus 3 cosine x plus 1. Combine like terms and multiply each side by -1. We end up with this now. Now we're all on cosine. So now we can factor this further into 2 cosine x minus 1 cosine x minus 1. Now we can solve for our zeros here in that situation. For 0 and 2 pi, x equals 0, x equals pi over 3, and x equals 5 pi over 3. Because cosine x is a period of 2 pi, the general solution would be x equals 2n times pi, and this would be x equals pi over 3 plus 2n pi, and then x equals 5 pi over 3 plus 2n over pi. So where n is an integer, the graph of y equals 2 sine squared x plus 3 cosine x minus 3 is shown right here. So these would be your zeros up here in this situation here, and that corresponds up here. Pi over 3 is here, and then 5 pi over 3 would be over here. Let's try one now. We have 4 sine squared x equals 2 cosine x plus 1. So we have that. We're going to move everything over on the one side here. We end up with this. And then when we do that, you can graph this now on your graphing calculator, and you can find zeros here, but what are they? So your x would equal 0.8614, which would be here, then 5.4218 would be over here. That would be your zeros there for your x-intercepts of the graph of function. Your notebook, students. Sometimes you must square each side of an equation to obtain a quadratic because this procedure can introduce extraneous solutions. You should check any solutions in the original equations if they are valid or extraneous. Well, okay, squaring and converting to quadratic. Find all the solutions of cosine x plus 1 equals sine x in the interval of 0 to pi. It's not clear how to rewrite this equation up here in terms of a single trigonometric function. Notice what happens when you square each side of the equation. So when we square each side up here, because we're kind of stalemated up here, let's square each side. There's your original. When we square both sides, we end up with something like this. Now we can kind of visualize Pythagorean identity, right? So when we have that, we end up with this here. Cosine squared x plus 2 cosine x plus 1 equals 1 minus cosine squared x. So we can produce Pythagorean identities up here. So now we combine like terms. Up here, 2 cosine squared x plus 2 cosine x would equal 0 here in this case here. How do we get there? We move this over here. This will be 2 cosine squared x. That's how we got that. Plus 2 cosine x. And then this will become negative, and that would cancel those out. So that's how we get that over here. And then now we can factor out 2 cosine x. Then we end up with 2 cosine x plus 1. Now we got something to work with. Setting each factor equal to 0 produces the following. 2 cosine x equals 0 and cosine x plus 1 equals 0. So cosine x equals 0, cosine x equals -1. So when we have that, now we can come up with the radian values for this situation here, pi over 2 and 3 pi over 2. And then x would also equal pi in this situation here. Okay, let's get into our next part of this example here. Because you squared the original equation, check for extraneous solutions. So our check here for cosine pi over 2 plus 1, does that equal sine pi over 2? Substitute pi over 2 for x in this situation here. So this is 0 plus 1 equals 1. Yep, that one checks. So cosine pi over 2 checks. So cosine 3 pi over 2 plus 1, does that equal sine 3 pi over 2? So 0 plus 1 does not equal -1, so cosine 3 pi over 2 does not check. So cosine pi plus 1, does that equal sine pi for this situation? So -1 plus 1, does that equal 0 In this situation here, it does, so cosine pi also checks. So that's really the situation there. When you square stuff, you got to check for extraneous solutions. Of the three possible solutions here, x equals 3 pi over 2 is extraneous. So in the interval 0 to pi, the only solutions are x equals pi over 2 and x equals pi. The graph of y equals cosine x plus 1 minus sine x is shown. That's this curve here. And this confirms this result because the graph has two x-intercepts at pi over 2, which is here, and then x equals pi is here, in the interval of 0 to 2 pi. So that's the way you check it, is with your graphing calculator. Let's try this one here. Cosecant x was cotan x equals 1. So putting this into, let's break it down. Let's just put it that way. Y equals 1 over sine x plus cosine x over sine x minus 1. So basically we're going to move this over here, or 1 over there. And then x in this case would equal 5.708 or pi over 2 is what we're saying here when you get through combining your terms here. And then this would be your graph of this expression here when you put that on your calculator, so no doubt this is pi over 2. So that is 5.3 part 2 of your pre-calculus lesson today. If you need classwork sheets or homework sheets, email me here for that, or course materials or tutoring, online tutoring, I offer that as well. Email me here and I'll get back to you. Thank you very much.